I've been working on the roof rack, and I decided to go ahead with the solar panels for the roof. The main reason being that I'm going to be having a 12-volt refrigerator in there, and for it to run all day on just the batteries would soon wear the batteries down, and then for sure I would have to run the generator for a couple hours every day. So I'm adding solar to the top, and I decided to go all the way for another couple of reasons. I'm putting up 5 Renogy 160 watt panels, and so that's going to be for a total of 800 watts. The reason I chose those panels is between the supports here, this one on this side and the one on the other side, I have 62 inches, and the Renogy panel is something like 58 inches. So I can put them lengthwise running across the body of the van, and so that would maximize the amount of solar panels that I can put in the space that I have. The whole roof will be covered with solar panels basically. The only section that won't have panels is this section right in here where the vent is. Because there's 5 panels, an odd number, I couldn't pair them up for a 24 volt array or system, so I had to go with the controller that would handle the total amperage of 5 12 volt panels. And then so I went with an 80 amp controller to give me a bit of a safety margin. And this is a hybrid panel. They call it, it says it's an MPPT, but it's actually a hybrid. It's not a true MPPT. It's part of it's the other style, PWM, I believe, pulse width modulation. But it'll handle the current, and with the amount of panels that I have on there, I don't need the efficiency of a true MPPT, and I couldn't find one at a reasonable price that would handle that kind of amperage. So the panels are in order. When they come in, I'm going to wire them up so that they enter into this fuse block here, and each panel will have its own fuse, and this fuse block combines all of the circuits, and it'll come out here and feed the controller, and then in turn the controller will come out and feed the batteries. All the negatives will be attached to this bus bar here for the solar panels. And so anytime in the future I want to test an individual panel, it'll just be a matter of pulling the wire off of the terminal and then taking a voltage reading or amperage reading on that one panel, and then putting it back on, checking the next one. So if I have a performance loss, it'll be fairly easy to troubleshoot. Let's see, I'm going to be shooting into the sun here. Let me move the ladder to the other side of the vehicle, and I'll show you what I'm doing. I went with plenty of these cross members, these ladder racks, because they were cheap enough, and having a lot of support, keeping the solar panels from flexing, I think will help them last a little bit longer. These nuts that I'm using here are actually made to go on the inside of this channel here. These you find these at the big box store in the electrical department, and this will be what the brackets for the solar panels will be actually bolted to. I don't know what the exact width of the panels are going to be, because you know, I might have to space them a ways from each other for the bracketry to mount them. So my plan was to start here in the very back by the roof vent, and then install them going forward, and then when I run out of panels, I can trim these mounting brackets to the correct length, and hopefully the remaining pieces that are cut off will fit on the rear section. There'll be one panel going across the back behind the vent, and that panel should also cover the roof vents that I have that I put in there to keep the rain out. So Renogy hasn't shipped the panels yet, so I imagine they'll be doing that in a few days. So maybe within a week's time, I'll be able to move forward with this. As I said a little bit earlier, the reason why I wanted solar was for a 12-volt compressor refrigerator. But the reason for the number of panels that I'm putting in is also that they'll cover the roof and keep the roof out of the sun, for one thing. But I'm also running an air conditioner, and hopefully during the heat of the day the solar system will be able to also run the air conditioner. When I run it off of the inverter, I measured the current as being 35 amps coming out of the battery, and in theory this 5 of the 160 watt panels has a potential of putting out 800 watts or over 50 amps of power. So theoretically it's doable, but we'll have to see. It's going to be a time will tell type of thing.